All right, this video right here will go through the finals, the most important 16 questions that I picked out over the 4 main units that we did in Algebra 2 for the exam. So I picked out number 1 here, just to get us going, no big deal. This part here means n minus 1. If you remember sequences, this is the first term, the second term, the third term, the fourth term, the fifth term. And we start with n equals 2 because we're starting with the second term. So what do? This means previous term. N minus 1 was previous term. So it's the previous term plus 3, the previous term plus 3. So starting with the second term, which is where I'm starting at, it's the previous term plus 3. So it's going to be 8. Previous term plus 3. So it'll be 11, and then 14, and then 17. So this means the previous term plus 3, the previous term plus 3. That is in not explicit formula, but in recursive formula, because it has to ka-chunk out. This one is an explicit formula. I could make n is equal to any number I want to and jump all over the sequence. Here I have to go ka-chunk, 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 add 3, add 3, add 3. But this is a formula, an explicit formula. I can go anywhere that I want to. So this is the first term, this is the second term. So the second term, just put in 2 there. 2 minus 1 is 1, so it's 1.5 times 2. Well, 1.5 times 2 is 3. And then what you're really doing is you just go to the next power here. So n is now 3, so you're going to do 1.5 squared. So you're just multiplying by 1.5 over and over again. So 3 times 1.5 is 4.5. And then you just keep multiplying by 1.5. And again, you can jump to any term you want to. Let's do the fifth term. It's 2 left parenthesis 1.5 to the power of 5. Whoops, back up. To the power of 5 minus 1, which would be 4. So that term right there is 10.175. And I jumped right to it. I don't have to go in order with this. 10.175. That would be the fifth term. Now n is 4. So, excuse me. So I do 2, and then I do 1.5 to the power, which is 6.75. See, 6.75. So let's see. You could also just do this. Once you recognize you're multiplying by 1.5 over and over again, you go 2 times 1.5, enter, and then times 1.5, enter, and then you just keep hitting enter, 1.5, 1.5, 1.5 forever. All right, now we're supposed to write the explicit formula for this. If it was arithmetic means you're adding every time, and then geometric, we're supposed to write it out as geometric, which means we're multiplying every time. Need to get a drink here. Okay. So if you're thinking about this as arithmetic, you would be 1.5, and then you're adding 1.5. So I would do 3, and then I would do 4.5, and then I do 6, etc., etc. So I'm adding 1.5 every time. So when you do the explicit formula, you do f of, well, it's h, I guess. H of n is equal to, you do the starting amount, which is 1.5, plus the change, like slope, 1.5 times n. But if you don't put a minus 1 here, it won't work, because it needs to be 1 minus 1, which is 0. So then the first term is 1.5. And then the second term, you put in 2. And then that would be 2 minus 1. So you're only adding on 1 of those. So you have to have this n minus 1 there. Now if you distribute it, you can simplify and make it look differently. But this works. So h of n is equal to 1.5 plus 1.5 n minus 1. Now we have to do the same thing with the next one. Oh, and then we have to find the 140th term. Okay, so h of 140 is equal to, and I did this to you so you wouldn't have to you wouldn't have to like type in the button 140 times, so we can go jump right to the 140th term. So it's 1.5 plus 1.5, and then you're not adding 140 1.5s, you're doing 139 because it's n minus 1. 139, enter. So 210 is the answer. 210. All right, now we need to think about a second way. So we're going to think about it with multiplication. Double. 1.5 times 2 is 3, so I would double it every time. So this is kind of like y equals ab to the x. So I do h of n. I need a starting amount of 1.5, and then I double, and I double it a bunch of times. So I do n, but I need the first one to be 1.5, so I need the n minus 1. But this is like ab to the x, the thing we studied a whole bunch. And then here, this is like a line. We have a starting point and slope. You just need this n minus 1 so that the first term is this number. If you didn't have the minus 1, then the first term would be like 3, and that's not what I want. I want that to be the first term. So hopefully that makes sense, this transition from linear to exponential a little bit more now. So I want the 16th term. The reason why I did that is because these numbers get really super big really fast. So we're going to do 2 to the 16 minus 1, or 15th power, because it's 16 minus 1. And I type that in the calculator, I get 49,152. All right, then the last one on chapter, or unit 1 that I wanted was this one. And I wanted an explicit formula. Not explicit, sorry, recursive formula. And I can tell because I had to give the first term. Well, this is, if you don't look at it right, so you're basically, this right here is sitting right there, right? But I just added 4, which is the same as the step size. And then this right here is sitting right there, but I just added the step size. So it's the previous term, which is the notation n minus 1, plus the term number. So plus n, the term number. So basically, I just took these 3 and put them over here, and then I added 3, which matches that. And I took these 6 right here, put them there, and then I added 4, which matches that. So it's that plus that. Starting not at the first term, but starting at the second term. So n is greater than 2. So there is that. All right, for x-intercepts, you want to know when is the function equal to 0. What makes the function 0? Where does it cross the x-axis? So we do 0 product proper super t. X minus 3 is equal to 0. X plus 5 is equal to 0. And 2x minus 5 is equal to 0. So you set each factor equal to 0. This is factored, so I don't have to do anything except for setting the factors equal to a 0. Subtract 5 over, and I get negative 5. Add 3 over, I get x is 3. Add 5 over, 2x is 5. Divide by 2, x is 5 halves, or if you want to have 2 1/2, whatever makes you happy. Okay, the next question is, this one we did the polynomial division, and you know, this is something we spent quite a bit of time on, so I think it's worth going back and hitting it again. So we get x plus 11, x cubed plus 10x squared minus 23x minus 132. And the thing about this is I know that there's going to be a remainder of 0. How do I know there's a remainder of 0? Because it says that this is a factor. It's a known factor. So I pick out x squared. Pick it out, multiply it out, and then subtract it out. For subtraction, I use the red pen. So that cancels out, and it's negative 11 plus that would be negative 1x squared. Drop the next thing down. Pick it out. Well, I have the x, I need an x squared, and I need a negative 1. That times that is negative 11x. Okay, both negative, but then when I subtract it, it changes to positive. So that'd be negative 12. then I need a negative 12, and 11 times 12 is negative 132. So this is going to match up exactly. And since it matches up, when I subtract it out, I get a remainder of 0. So that's the dividing part of it. But now we know that the x plus 11 multiplied by x squared minus x minus 12 is equal to 0. X plus 11 x minus 4 plus 3 is how that would factor. And we'd use the officer bell half donut trick to make sure that it factored. All right, and that's what p of x is equal to, equals p of x. So here it is in factored form. I don't need the equals 0. I should have written p of x equals, so p of x equals this. So p of x is equal to the factor x plus 11, which was known, the next linear factor. By linear factor, it's x to the first power. And there's the answer. So this is standard form here, factored form there. Now we get to find the x-intercepts by factoring. So we set the factor equal to 0. Minus 9 minus 1, that would make negative 10 in the middle. 0 product proper t, so we set each factor equal to 0. Add the 9 over, x equals 9. Add the 1 over, x equals 1. So those are the zeros of the function, the x-intercepts. Okay, the last one here is to solve. So when you solve this, when you solve these, this was part of Unit 2, was solving these rational functions. So these are proportions. You cross multiply to solve proportions. So it's 10 times 4 minus x, 2 times 4 plus x. So 40 minus 10x is equal to 8 plus 2x. So we get the x's on the same side by adding the 10x over. I get 40 is equal to 8 plus 12x, so let's get added together. Subtract the 8 over, that'd be 32, is equal to 12x. Then we're going to divide by 12. That doesn't come out even, so we could leave it as a fraction. 32 divided by 12 is 2.6 repeating. If you want to see the fraction, you do the math. Fraction 8/3. So it's 8/8. All right. This is all about exponents. So when you multiply like bases, you add the exponents. All right, now on to Unit 3. I don't know if I said that. Somebody came in my room. I got interrupted and all the 9 yards. Okay, so when you multiply like bases, you add the exponents. That was a basic rule. And this is the most basic rule. 7 plus a negative would be 3. So how about negative 4? When you solve these, you have to isolate the radical, which is isolated. So you just do the opposite power. So we square each side, it'll be the opposite of square rooting. And obviously not 20, it's 100. Then we can do regular algebra and divide. And of course the answer is 50. Now solve by factoring. So there's a couple of these. I must be kind of big on the solving by factoring thing. And we get x, and then 10 and 5. Now that'll make 50 and 15. So we get x plus 10 is equal to 0, x plus 5 is equal to 0. Negative 5, 10. And we kind of did a zero product property already. Quadratic formula. That's the A. That's the B, which is -1, and that's the C, which is 3. So it has to be in order. X squared, X, number, it has to be equal to 0. That's how you identify A, B, C. So it's AX squared plus BX plus C. That's the standard form of a quadratic. So, we have negative B, so it's a double negative, so it'd be 1, plus or minus square root 2A, 2 times A. Well, A is 3, so it's going to be 6. And then I switch colors to green because I always did. And it's B squared, so it's -1 squared minus 4A was 3, I already said it. C is also 3. So this is one of those where we're going to get a negative number under here. So make sure you type this in correctly. So it's going to be -1 squared minus 4 times 3 times 3. So -35. -35. So we get x is equal to 1 plus or minus the square root of -35 over 6. Now, we break this up into the square root of -1 and the square root of 35, because the square root of -1 is that I business. So this is an imaginary solution, I square root of 35 over 6. So that's the answer to that one. Now, unit 4, unit we just got done doing, AB to the x. So y is equal to A, the starting amount of the house, $85,000, 3% a year, so growth rate 3% a year, and then just 8 years from 19 to that. So we type this into the calculator. 85,123, parentheses 1.03, parentheses to the power of 8. 107,000. So I'm going to do cents, dollars and cents. So it's 107,675.6. So it's a nice game. At one point during the 90s, houses were going up at 3% a year, average across the country. Pay it up. Log base 2 of 8 is 3. There's the base, there's the exponent, there's the answer. I picked this one, but I decided to do this one because the E solving is on the next page, so the last question. So divide by 8. So you got to do basic algebra first. So it's 600 divided by 8. 75. Now I want to have the exact answer and then an approximate answer to 3 decimal points. So you can kind of know what you're looking for here. If you do 6 to the second power, that's 36. If you do 6 to the third power, that's too much. So the answer has to be between 2 and 3. Well, let's find it. So we do log base 6 of 75 is equal to the unknown, and we just released the exponent. We just solved for x by doing that. We type this into the calculator. We hit the math menu. We go up a couple spots. We got log base 6 and 75. I told you it was between approximately equal to 2.410, because I would do that and then I would change that to a 1 or round up on that, which makes it 10. So there's 3 decimal points there. Okay, the last question of the 16. I picked out 4 questions on each. Picked 4 questions on each one. And some of them are easier and harder than others, of course. Okay, it's the Old Town population. It's in thousands, so that's not 9.5 people, it's 9,500 people. The growth rate's right there, 1.5%. And then we have T is equal to 15,000. 9,500, 9,500, e to the 0.015 t is equal to, we're going to divide this out, 15,000, 1, 2, 3, divided by 9,500, oops, is a terrible decimal, so I'm going to change it to a fraction, and it's 30 over 19. Now, bay it up. When we bay this up, it's natural log, because it's log base e, which is natural log of 30/19 is equal to 0.015 t. Divide over, and that's the exact answer. So t is that fraction divided by that decimal. So we go clear, natural log of 30 divided by 19 divided by 0.015. So t is equal to 30.451 years. So when did it happen? Well, basically 2050, because you go 30 years past 2020. All right. All right, in the year 2050. So that's it. That's the review. So go through, hopefully you've gone through this kind of a chunk at a time instead of all at once.